Welcome back, everyone. Today we're going to be learning about basic derivative rules and how they can be applied in different situations. So first, the most essential idea that you should already know, but I'll review, is that the derivative of a function at a certain point is a measure of the slope at that point. So what are we going to be doing today, and how are we going to be doing it? Using basic rules, we're going to learn how to differentiate a function no matter what it looks like. And why are we going to be doing this? What's the purpose of this? The purpose is to be able to quickly and easily find the slope of a nonlinear function at any given point. This has applications in medicine, chemistry, bio, essentially any data-driven science. For example, in chemistry, when doing a calorimetry experiment, when you mix two elements together and you're trying to measure the change in the transfer of heat, you often lose some heat from where it should be when it mixes. So by using the derivative at this point, we can find the slope and then determine what the actual original temperature is when mixed. That's also extrapolation. So the first rule we're going to be looking at is the constant rule. Essentially, the derivative of a constant function is 0. So since we know that the derivative of a function at a certain point is its slope, this makes sense because if you have a constant function like f of x equals 3, the slope is 0, so the derivative is going to be 0. The next rule we're going to be learning about is the power rule. It's represented in function notation here, and essentially what you're going to do is you're going to bring the exponent down and then replace the exponent with a value 1 less than the original. This might be a little confusing when explained, but in practice it's pretty simple. So for example, x squared, you'll bring the 2 down in front, so that's 2x, and then 2 minus 1 is 1, so it's to the power of 1, the new function. And if there's a coefficient in front, this is a slightly different rule. It's called the constant multiple rule. All you have to do is multiply the value of the exponent by the coefficient that's already in front. So here, 3x cubed would be, bring the 3 down, 3 times 3 is 9, 9x, 3 minus 1 is 2, 9x squared. The next rule we're going to be looking at is the sum and difference rules. So essentially this rule is just if a function has multiple parts and each part is differentiable, take the derivative of each and find either their sum or difference. It's also applicable if you're asked to combine 2 or more functions, such as add f of x and g of x, and then you want to find their derivative. You would first find the derivative of f of x and then find the derivative of g of x and add it together. So an example of how this might look, a question like this, to derive this, we can obviously see many different parts in this equation, and we would differentiate each using a different rule, the power rule, the constant rule, and then we would from there get the derivative of the function overall. Another last rule to keep in mind is trig identities and derivative rules. This is also applicable in reference to trigonometry, and so you want to have these rules at your use. So essentially, anytime it has a co in front of it, cosecant, cotan, cosine, the derivative is going to be negative. That's a quick trick to remember, and you just want to memorize these trig identities because they'll come up, especially when differentiation gets more complicated later on. So let's do some practice. 9x squared plus 8. Here you're going to use the power rule and the coefficient power rule and the constant rule. Since that's a constant, it's 0 is its derivative, and then you bring this down, 2 times 9, 18x. So this would just simply be the derivative of this would be 18x. The derivative of sine x is always cosine x, and it's positive, whereas if it were cosine x that we're trying to be differentiated, it would be negative sine x. Lastly, this one we're going to be using the sum and difference rules, and we have to look at the power rule here. If you bring down the 3, it would be 3x, then 3x squared, and then you would have 2, because that's just the rule for that. And then the constant rule is 0, so it would be 3x squared plus 2 would be the derivative of that function. Just one last thing, further application for this process. You can find the equation of a line tangent to a certain point, which is a type of problem that will be used later on and is very important. I hope this helped, and have a great day.